आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone, let's start with the question. The question says that explain giving reasons for the following. A. Photoelectric current in a photocell increases with the increase in intensity of the incident radiation. B. The stopping potential V0 varies linearly with the frequency V of the incident radiation for a given photosensitive surface, with the slope remaining the same for different surfaces. C. Maximum kinetic energy of the photoelectrons is independent of the intensity of incident radiation. Let's solve the question. A. So the first part of the question A, the number of photoelectrons, it is observed experimentally that as we increase the intensity of the light or photons, we see more electrons being emitted. Why is that? Because when we increase the intensity of light, we bombard the metal plate with more photons. So if we bombard it with more photons, we see more photoelectrons coming out. And photoelectrons are electrons that are emitted because of the photoelectric effect. So the number of photons emitted per second increases if the intensity is increased. So the photoelectric current increases. So for the first one, the number of photoelectrons emitted per second increases if the intensity of the incident light is increased. This is the reason we see the photoelectric current also increasing, because more photoelectrons are being emitted. Now for B, the question asks us, the stopping potential V0 varies linearly with the frequency V of the incident radiation for given photosensitive surface, with the slope remaining for the same for different surfaces. Now why is that? So we have observed that if we increase the intensity of light, we see more photoelectrons being emitted. But when we increase the frequency of light, we see that the photoelectrons that are being emitted have more kinetic energy, and stopping potential is the energy or the potential difference required to stop the photoelectrons, and this is directly proportional to the kinetic energy of the electrons. So higher the kinetic energy, the more stopping potential we require. So if we increase the frequency of the incident light, we see that they have more kinetic energy, and thus our stopping potential increases linearly with it. So we can write this as EV0, where V0 is our stopping potential, is equal to h mu minus h mu naught, where h is Planck's constant, mu is the frequency. So V0 is given by h by E times V minus hv0 by E. So as V0 increases, V is a straight line. So V0 versus V, when we plot this graph, so as V0 increases, this means that the kinetic energy of the electrons is also increasing. That is why we have a constant slope h by E. So V0 versus V is a straight line with a constant slope h by E. Now for the next part of our question C, we have already discussed that the kinetic energy of the photoelectrons being emitted depends on the frequency of the incident light, not the intensity. The intensity only increases the number of photoelectrons being emitted. So mathematically we can write this as K max. So the maximum kinetic energy is given by hv minus hv0. We see that it's dependent on the frequency, not the intensity, which we can write this as hv minus phi naught. So the maximum kinetic energy of photoelectrons is independent of intensity, because we do not have intensity in this equation. It's dependent on the frequency. Alright. So with this we can conclude our answer. Therefore, A, as intensity of incident light increases, photoelectric current increases. Why is this? Because the number of photoelectrons being emitted is directly proportional to the intensity of the incident light. For B, V naught or stopping potential versus the frequency is a straight line. Straight line with a constant slope. For C, kinetic energy of photoelectrons independent of the intensity of incident light. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।